Ever wondered why the current energy sources we rely on are just not enough? Why is there an energy crisis? You see, our traditional energy sources are finite and they're running out. Moreover, they're causing considerable harm to our planet. Coal, oil, natural gas, these are all fossil fuels, and their extraction and usage are leading to a range of environmental problems, such as air and water pollution, habitat destruction, and most alarmingly, climate change. The global demand for energy is only increasing, and with it, so is the strain on these finite resources. We're in a quandary, a conundrum of our own making. We need energy to power our world, but the cost of this need is becoming too great. The time is ripe for a solution, for an alternative that's both sustainable and kind to our planet. But what if there's a limitless, clean energy source right under our noses? Enter the world of zero-point energy. Imagine an energy source that never runs out, a source that doesn't harm our planet. This is zero-point energy. Now, what if I told you that this isn't just a pipe dream, but a concept grounded in the realm of quantum mechanics? It's a fascinating world where particles like to keep moving even at absolute zero temperature, refusing to be completely still. This leftover energy, the smallest possible amount a system can have, is what we call zero-point energy. But like every good mystery, understanding zero-point energy isn't straightforward. It's where the McGinty Equation, or the MEQ, comes into play. Picture this equation as a key that helps unlock the secrets of zero-point energy. Now I know what you're thinking. Equations, I thought we were talking about energy. Well, the McGinty Equation is our bridge between the abstract world of quantum mechanics and practical applications of zero-point energy. It's a mathematical model incorporating elements of quantum field theory, the intriguing concept of fractals, and the fundamental force of gravity. The equation, in its simplest form, is comprised of two main parts. The first part, the quantum field theory component, represents the behavior of particles in a quantum state. The second part, the fractal component, introduces a self-similar structure, a pattern that repeats itself regardless of the scale. This fractal component introduces a new dimension to our understanding of energy systems. But there's more to the equation than just these two parts. It also includes a gravity component, representing the effects of gravity on the quantum field. This addition of gravity makes the McGinty Equation a comprehensive model for understanding zero-point energy. Yet the true beauty of the McGinty Equation lies in its potential. It's not just about understanding zero-point energy, it's about harnessing it. From green energy generation to advanced materials manufacturing, the implications of this equation could revolutionize our world. The McGinty Equation allows us to better understand and potentially harness zero-point energy. As the journey unfolds, we'll delve deeper into this exciting world where science, mathematics, and sustainability converge. So what exactly is this McGinty Equation, and why is it important for zero-point energy, you might ask? Well, don't fret, we're here to unpack this scientific wonder. In the realm of quantum field theory, the McGinty Equation, or MEQ, plays a crucial role. It's a unique formula that weaves together the complexities of quantum fields, fractal effects, and gravity, providing a comprehensive understanding of the elusive zero-point energy. Let's break it down, shall we? The McGinty Equation is expressed as piece xxt equals sign piece qft xt plus piece fractal xt dmqs. Here, piece qft xt is the solution of the free quantum field theory, and piece fractal xt dmqs represents the intricate fractal effects. Now, if you're scratching your head over the term fractal, think of it as a pattern that repeats itself indefinitely, no matter how closely you look. These self-similar patterns are found everywhere in nature, from snowflakes to tree branches, and even in the quantum realm. But the McGinty Equation doesn't stop there. It's also been modified to account for the gravitational effects on the quantum field. This modified equation, piece xt equals sign psqft xt plus piece fractal xt dmqs plus piece gravity xtg, introduces a new term, piece gravity xtg, where g characterizes the strength of the gravitational force. So how does all this relate to zero-point energy? In essence, the McGinty Equation allows us to better understand and potentially harness this limitless energy source. The equation takes into account the quantum, fractal, and gravitational aspects of the energy field, providing a more comprehensive picture of zero-point energy. It's like finally having a map for a previously uncharted territory. Indeed, the McGinty Equation is complex, but its potential is revolutionary. It's more than just a mathematical formula. It's a key to unlocking a sustainable future powered by zero-point energy. With the McGinty Equation, the previously intangible concept of zero-point energy becomes a potential reality. Now that we understand zero-point energy and the McGinty Equation, what does this mean for our future? Well, let's imagine the possibilities. With zero-point energy at our fingertips, we could revolutionize the way we generate power. No more coal or gas, no more nuclear. Instead, we tap into the infinite reservoir of energy that's all around us, invisible to the naked eye, but as real as the air we breathe. Green energy generation would be more than just a buzzword. It would be our reality, but the potential of zero-point energy doesn't stop at power generation. Picture a transportation industry driven by this limitless energy source. Cars, planes, trains, all powered by the energy of the vacuum, leaving behind no emissions, no pollution. We could travel the globe with a minimal environmental footprint. And think about manufacturing. With zero-point energy, we could create advanced materials and products without the energy constraints we face today. The manufacturing process could be transformed, becoming more efficient, more sustainable, and less resource-intensive. Now, harnessing zero-point energy is not without challenges. It involves manipulating the quantum field, which is no small task. But this is where the McGinty Equation comes into play. By incorporating fractal and gravitational effects, the MEQ provides a comprehensive understanding of zero-point energy, potentially paving the way to harness it effectively. So while we're still in the early stages of this journey, the McGinty Equation offers a promising path forward. It's a tool that could unlock the tremendous potential of zero-point energy, turning what seems like science fiction into science fact. As we venture into the future, zero-point energy, guided by the McGinty Equation, could be our key to a sustainable, energy-secure world. And while the road ahead may be challenging, the rewards could be immense. A world powered by zero-point energy is a world where sustainability is not just a dream, but a reality.